I'm good. Thanks, George. How are you?
No bad. Can you see my screen? AKS cluster architecture.
Yes, I'm saying.
That's great. Let's record something and explain what's AKS. It's for Azure Kubernetes Cluster or Azure Kubernetes Service. That's a service on Azure that you can, have a fully managed Kubernetes cluster. And the question I think you asked me before was, can you explain what a Kubernetes cluster is? The first thing, the cluster is like a group of nodes. Nodes, it means like a VM, a virtual machine. And you can see on this diagram here on the right side, you can see the nodes. Nodes means VMs. How we can manage multiple VMs for that to become like a single thing, like a single cluster. Imagine if you have like two VMs with 2 cores and 4 GB of memory. I want to see that as 4 cores and 8 GB of memory. I don't care where my application is running. I want to see it as this like a big machine. But we need someone in between. That's exactly what Kubernetes is, to manage those machines. Okay, and Kubernetes is nothing more than an API server that we can talk. This API is exposed as a gRPC API. It's not like a REST API. It's a gRPC API. Okay, it's a different way to communicate with this cluster. Then we just call. Okay, there's different ways to communicate with this API server, like command line. There are some tools that you can manage Kubernetes as well. And let's say I'm calling this API and say I wanna run my application. And I send what is known as like a YAML Kubernetes configuration file that you sending for this API server as an API call. This API server is translated that and scheduling that application to run inside those nodes or those clusters. But we don't know where the application is going to run. Let's say I have an API and a front-end web application. Okay, I have two pieces of software that I'm going to deploy, and I'm just asking Kubernetes, can you deploy those containers? Because Kubernetes is all about containers. Okay, then we're not deploying any like a process. We deploy containers. That's what we call Docker containers. I'm not going details what a Docker container is. I think is a minimum that they have to know what's a Docker container here. And Kubernetes is a orchestration layer on top of of containers and on top of these nodes and those servers there. Then Kubernetes manages software deployment, managing VMs, hardware, managing networking, managing connection with the storage, and it's pretty much orchestrating those things. And then when you say, can you deploy this application for me? Then Kubernetes use that scheduler to just look for the nodes that they have available on the cluster. Let's say we have 2 nodes, and they try to find a spot there to deploy the application.
Like the node with the resource free to run the application, the best node to run.
And look, okay, this node has some resource free, and on that YAML definition that you asking for the API server, I say how much memory you need, how much CPU I need for that application to run. They're going to find a node where they have available CPU and memory to run that application, and you're going to run. It's very complex. Then I'm simplifying here.
That's
And
but a good point is for Kubernetes is essential. You need to specify the requirements to run this application. How much memory do you need? How much processors to allow the Kubernetes to choose the best node to run, right?
correct. And there's a few components. Kubernetes keeps all that configurations, stored on using this database called etcd. It's an open source on Cloud Compute Foundation. It's part of the foundation. And it's pretty much each node runs what they call kubelet. Okay, it's a piece of software that runs on each node that Kubernetes talk with that kubelet and asking for those things to be created. Because Kubernetes using containers, then they also separate what they call container runtime, that will be Docker. Okay, don't have to be Docker, could be just containerd, but let's say using Docker here. And then Kubernetes said, Docker, can you create the container for me? And they create the container. Kubernetes creates something even more. They create something called pods. Pod is like a group of containers, okay? We're not going details there, but keep in mind that's a container that's running, created by a container runtime like Docker. And the kube proxy here on each node is a lot of routing magic happening here, and we don't go in details, but all the routing for each node is done by this guy. And if you ask me what happens if this node where my application is running fails, if this node's down, what happened? What happened is Kubernetes is watching those nodes with like probes. And if that node fails, they're going to schedule the application to run in another node. That's done automatically. You don't have to say, okay, my application is down, can you run again? No, that's what they do for us. And Kubernetes just say, okay, I'm going to schedule another node.
Okay, this is the reason Kubernetes is a high availability service, right?
Correct.
Yeah.
And on AKS, there is one thing called cluster outscaler as well. Let's say if the scaler need to deploy application, but there is no CPU and memory available. What's happened? They're going to create the node number 3.
Oh, you outscale the nodes. They create new nodes, new VMs to run the containers.
Yeah, there are 2 ways to do outscaling. One is node outscaling. That's the physical outscaling because you don't have more resource available. Another thing is scaling your application. Let's say your front end need to scale because now have 500 people calling per second. Then Kubernetes is going to look that your application is using 9% of the CPU that you asked for, and is going to create another instance. Okay. And there is one thing in Kubernetes called service, where they're going to do the load balancing on those containers running. Then when you see like here that container, it could be multiple containers. And there's a load balancer managed by Kubernetes that's doing the load balancing in multiple instances of your front end or on your API, for example.
And you may contain the same multiple containers running multiple nodes, and you'll have the load balancer forwarding the traffic to the correct node, right?
Yes. Then 2 things separate here, outscaling of the nodes and outscaling of the application inside the nodes. Those instance of your application could be, let's say, you need 5 instances of your front end, could be 3 running on node 1, 2 running on node 2, and 1 running on node 3. But you don't have to care where those things are running. Kubernetes is going to manage this balance for us. And that's help with, if one node fails, the application is still running. And high level is like that. If we go in details on the networking side of Kubernetes, like I said, when the kubelet call Docker and Docker creates the container, there are 2 things you can do. You can connect one Azure disk on that. Okay, if you're running Kubernetes on Azure, you can use Azure disk or Azure files. Then you say, I'm going to attach a 5 gigabytes disk on my container, on my front-end container. If you use our Azure files, you can connect these on all the instances. Let's say I have 5 instances of my front-end, and I have of my API, because front-end normally are stateless. But if you need like a stateful application, where you're going to record like files, let's say your front end called the API is running here, and the API is saving some files on the Azure files. That can be connected. When you create the container, you can attach these.
Yes, just remember the Azure files is the NFS network file share for Azure, and the Azure disks are the block storage. The block storage you can connect only to one container, but the Azure files you can connect several containers at the same time.
Correct. Each one of the types here, there are different, features and pros and cons. Yeah, but that's one of the reasons that Azure file is better when you want to attach to multiple instances, and that's most of the case. And That's what I was talking before about the networking, about the queue proxy as well. And you can see the queue proxy here talking with the VNets. Means is when you create your cluster, you're going to connect your cluster inside a virtual network. You can even say, I want a private cluster. I want a cluster that nobody can access this cluster from outside my virtual network. You can do it. And one way is, what they call Azure CNI. That's a network interface for Kubernetes, and that you can integrate Kubernetes with multiple different types of network. Azure CNI is a way to connect with Azure Virtual Network, and that is the communication with the proxy and routing. Even if you want to say, if I want to from that container access something that's running on my virtual network that's not inside my cluster, let's say Azure service or something running inside a VM, you can use that integration to talk with those servers, and those servers can talk with your cluster as well. Means that for each pod or container, we call pod, you can have one IP on the VNet. Then it's pretty much a VM. Is most of how VM works. You have IP number for each pod. You can talk directly with that pod if you want from the VNet. And you can use service like on the VNet now, service endpoints or private links to connect with SQL Server running on as platform as a service. You can talk with storage accounts, Azure storage accounts as well. Means that it's a full service. You are inside a VNet. You can talk with anything that VNet can talk. But let's go a little bit further and see how flexible is Kubernetes is. If you go back and get all these Azure managed Kubernetes, and we put these inside a black box here, a blue box, we call hosted control plane. Okay, we don't have to care about this. It's a control plane where the Kubernetes master is running, all that scheduler. Microsoft managed that for us. That's free. Okay, there is no service levels agreement, but it's free. Now you can pay to have a service level agreement if you need it to, because for some you need to have more like support from Microsoft. You can pay SLA as well if you want, but it's a free service. And we don't have SLA, but have what they call SLO, service levels objective. That's we guarantee a level of service. But if there is outage here, we're not going to give any money back unless you be paying for the SLA.
Okay? But what happens if you have an outage? Your service still running on the same?
No, any service on Azure that have a SLA and have an outage, Microsoft going to pay you.
But on the Kubernetes, if the hosted control plane fail, what will happen? My application is still
that
running?
Control plane fail, application is still running.
Right.
Okay.
But don't scale, right? And like if some container die, it won't be relaunched, right? Okay, I got it.
Yeah. If one node fails, then the control plane is not watching, then it'll be a problem. Okay.
Okay.
But once that's back, everything will be back.
Yeah. Okay, but it's not a big problem. It will be like a short period of time.
Yeah.
If it happens.
And what happens is people wanna, even if you have a Kubernetes cluster, people wanna isolate the workloads in pools. That's why we created what they call AKS Node pools. Node pools is like a group of VMs. You can see this agent VM is just like a node VM. You can have a pool of Linux VMs or a pool of Windows VMs. We don't have ARM yet. I just put here as a sarcastic thing, but I think that'll be the feature. But we have Linux and Windows. Means that I can create a group of VMs. It's not like 8 VMs. You can create, bigger number of VMs. Minimum will be like 1 or 2 VMs. I think to be in production will be minimum 3 VMs. And I can have a pools, not just one. I can have multiple Linux pools, multiple Windows pools. And that's running Linux containers, that's running Windows containers. Windows containers now in production. It's available on AKS. You can run, production workloads now. Was published last month. Was made available, fully available after a long public preview. Now we can deploy. And that's That's how you do it. If you don't know about these green box, ACI means Azure Container Instance. Azure Container Instance is like running a container or a pod as one piece. Okay, I don't want to manage infrastructure. I just want to run that container. You can use ACI, and you have this for Linux and Windows. And now there's a way to connect ACI with Kubernetes using this project called Virtual Kubernetes. It's an open source project. And AKS has one thing called Virtual Nodes. That's pretty much, serverless Kubernetes. ACI integrated with Kubernetes will be serverless Kubernetes. Oh. You just need a minimal like of one Linux pool, one Linux pool with one VM at least, or 2 VMs in production, and you can run everything as serverless if you want. Means that you ask Kubernetes to run something, but Kubernetes asking for Azure to run that as a serverless. Okay, not going details. Cool. Maybe I can go in details on the cluster, but
yes, we can talk about that in the next video about ACIs. It's very interesting, but this is an introductory video about Kubernetes. So move on.
Yep, it's a serverless Kubernetes. Is a very interesting. Could be the next video for us. How that works with Kubernetes? If a Windows pool, that example is a Windows like 2 nodes Windows. We have a node pool with 2 nodes. We have a load balancer that's sending traffic. That could be application load balancer. And that's how it works on Kubernetes. Once I deploy something on those nodes, we can ask this Kubernetes deployment to be exposed as a load balancer on Azure. And that could be including like a public endpoint, a public IP. And let's say a web application that's going to be exposed to the internet, a public, application. You got a public IP, you map your DNS to this public IP, you get the traffic, and the traffic will be running on those containers. When you see the traffic is going to the node, not to the containers. When the traffic goes to each node, then there is a kubeproxy that's going to send the traffic to your to your service, and the service is going to send the traffic to your container. That's this gray thing running. That's your container. There's a lot of routing being happening here, but you don't have to manage that. That's the beauty of Kubernetes. It's all managed by deployment, by route tables, and the only thing I say is Kubernetes. I talk with these managed Kubernetes that's free. We talk as using a public. If it's exposed to the internet, we talk here using gRPC, and we say, Kubernetes, can you deploy this application for me? We don't have to manage this thing, and they're going to deploy the application. They're going to create the load balancer. They're going to create the public IP and do all the magic for us, and the application will be running. And if that node's not down, they're going to create another node. They're going to move the applications and and so on. And that's the Kubernetes. That's the magic. Okay. On the fully managed AKS, you cannot connect on that. There is no SSH to connect the nodes to see what's running there. It's fully managed by Microsoft. You can SSH on these or RDP on these nodes, but it's not recommended, to be honest. Let Microsoft manage these nodes. You can automate patching for these nodes as well. And there's a few techniques to to upgrade those nodes but let's move forward. I recommend you to have these installed if you want to work with Kubernetes. If you work on Windows, have the new Windows terminal, and the best way to work on Windows with Linux containers using WSL2, Windows Subsystem for Linux. Got Ubuntu or Penguin or any other distro available. You can use Azure Cloud Shell. That's available on the Azure portal. Docker for Windows is a must on these days. Even in work with Kubernetes, you can have a local single
WSL2. Yes, and with WSL2, this is essential.
Yeah, Fernando did a few videos. We did together videos about how to install Docker on on Windows, and that's now running inside Windows Subsystem for Linux. You don't even need a full VM anymore. It's very lightweight. And there are videos on azuretar.com. There's a WSL2 series there in English and Portuguese as well. And just watch, the YouTube channel. That's our logo. And these videos for Azuretar, and Fernando is helping a lot. And Visual Studio Codes with the remote extension for WSL and Docker. And you can use Visual Studio Code Space now. That's a new one. You run the whole development environment on the cloud. There are GitHub Cloud Space as well coming.
So even if you have a computer that you can't run Docker, you don't have run to run, you can run online it using CodeSpace.
Exactly. You can have the full Visual Studio Code running online now. Azure CLI, you have available inside the Cloud Shell, but you can install as well locally. Helm is a package management for Kubernetes that I recommend you to have a look. And you need a Docker Hub, okay, if you want to work on and publish things to expose to the public and write blogs and make Docker images available to the public. But let's go back here and let's just create a cluster.
Okay, let's do it as a part 2.
Okay, let's do as a part 2. We can stop here. I hope this was a good introduction to understand what Kubernetes means.
Yes, this is excellent. This is the first introduction. Now hands-on to create a cluster on the Azure.
Okay, let's stop everyone. See you soon.
See you.